Hey there, CJ Math students. Welcome to homework number 10. If you're out or absent, you can use this to help yourself get caught up. Or if you just want a refresher to study for a quiz or a test, you can use this as well. So remember that the commutative property, the order of the numbers does not matter. So 3 plus 2, which is 5, is the same thing as 2 plus 3, which is also 5. And then the associative property of addition, the grouping does not matter. So in this case, 2 plus 20 added first is 22, plus 3 is 25. And then if I do 2 plus 3, which is 23, added to 2, that's also 25. So notice the order of the numbers didn't change, just the parentheses just shifted down one, right? So that's the associative property. All right, so I tried to set up today's notes into different strategies for making complex addition problems of rational numbers a little bit easier. So the first strategy is borrowing from a whole. That's when you have a problem like 32 plus negative 12 and 7/8. You split 32 into 31, and then a whole of the fraction that you're trying to subtract or add, right? So 7/8, I make it 8/8. And then I use the commutative property of addition, and I say, okay, let me put my whole numbers next to each other, and let me put my fractions next to each other. So that's what I did there. 8/8 plus negative 7/8 is 1/8, and then 31 plus negative 12 is 19. We're using DSSM on both of those. That's how I got 19 and 1/8. So for number 2, 9 is split up into 8 plus 7/7 because it's out of 7 there. And so then, therefore, you're trying to put the wholes next to each other, which is 8 and negative 4, and your fractions next to each other, 7/7 and negative 4/7. Again, DSSM problem, we get 3/7 plus 4, so it's 4 and 3/7. All right, the next type of strategy is to simplify fractions. Sometimes you are given fractions that can be simplified or given a common denominator end up being the same exact fractions that you see in the problem. So number 3, first of all, it's important to notice we have 2 rounds of KCC that we have to do to this problem before we can even start it. And then hopefully you notice that 16 over 20 is the same thing as 4/5 if you divide it by 4, right? 16 over 20 simplified is 4/5. And so then all you're doing is putting 4/5 next to negative 4/5. That's 0, and that's how you get 1.8. You could also, instead of simplifying, you could also make it the same denominator. So in this problem over here, you'll notice we do KCC, 2 rows of it again, right? And then 8/12 is the same thing as negative 4/6 if I multiply negative 4/6 by 2. So instead of dividing 8/12 by 2, I could multiply negative 4/6 by 2, and then look, I get 8/12 and negative 8/12. So basically, you're just trying to get the same fraction there. Why? Because that's the additive inverse when I use the commutative property of addition. I do 8/12 plus negative 8/12, that's 0. I'm just left with 14, and that's how my answer is 14. Okay. The next strategy is converting fractions and decimals and spotting the additive inverse. So if I convert, first use KCC here, I get negative 5.2 plus 3 and 7/10 plus 5.2. Hopefully you recognize, the additive inverse is right there. I didn't even need to convert any fractions or decimals there. It's just 3 and 7/10. The next one, a little bit trickier, no KCC needed, but hopefully you recognize, wait, 12.125 and negative 12 1/8. Hey, wait a second. Yeah, 0.125 is 1/8. So it then just becomes, wait a second, I've got 12 and 1/8 and negative 12 and 1/8. I put those together, that's 0, additive inverse, and I get negative 3/4. Okay. The last strategy is making a whole. I'll do this one with you. So you'll notice we'll just have one little KCC here at the end. So KCC. So that means I have 3 and 4/5 plus 20.9. Change that to a plus sign, change that to a positive, so 7 and 1/5. Let's use the commutative property of addition to put 3 and 4/5 plus 7 and 1/5 next to each other plus 20.9. And then let's even do this a little bit more and say 4/5 plus 1/5 plus 3 plus 7 plus 20.9. Hopefully you'll see there what I did was I took the whole numbers and I put them next to each other, and I took the fractions and I put them next to each other. Why did I do that? Why? Because 4/5 plus 1/5 is 5/5, which is really just 1. So this turns into 1 plus 3 plus 7 plus 20.9. And when I add all that up together, I get my answer of 31.9. It was that whole thing of being able to see that these fifths actually give me one more whole, and so really I'm just adding a whole bunch of whole numbers plus that decimal. All right? I'll leave you to do 8, and the rest of these I want you to pick a strategy, one of the 4 that we talked about, to solve those. Call me if you have questions.